P. Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. Especially this lecture covers about connection establishment in the GSM network. We all know that the GSM users are connected with the GSM network through the air medium. The GSM users are to be allocated with the radio channels. So, how to allocate the frequencies and how to establish the channel to the users, that we will discuss today. GSM provides mobility to the GSM users. So, the mobility users are connected with the GSM network. So, connection has to be established between the users and to the network. In GSM, the connection can be established between the two entities. Now, one entity may be the GSM mobile station, the GSM cell phone, and the another one entity may be the mobile station of the same service provider or some other service provider. Sometimes a mobile station of the GSM network can make a call to the PSDN, that is the fixed users. So, two type of entities are used in this context. Automatic worldwide localization of users is the fundamental feature of the GSM system. So, the GSM always ensures about the automatic localization of the GSM users. As the GSM users are moving from one place to another place, their location has to be located for establishing the connection. So, without the knowledge of or without the involvement of the users, the GSM does the automatic localization. So, worldwidely the users can be located. Because of the automatic location management, the GSM always knows about the current location of its users. The location management ensures the periodic location updation. So, whenever the user is entering into the new visitor location register, so the particular location has to be updated with the HLR. So, the periodic location updation is mandatory in the GSM network. The periodic location updates is possible only when the MS is logged on into the GSM. For example, if a mobile user is switched off his mobile, then the GSM network is not able to locate that user. So, to do the periodic updations, the user has to be still logged into the GSM network and the mobile station should not be switched off. In the previous lectures, we have discussed about the visitor location register. This register or this database is responsible for doing the periodic updations of the users. Now, The VLR or the current location area is not a precise geographical location. Actually, the data in VLR does not give the exact latitude, longitude of a user. Instead, it gives the current location area. After collecting the information about the mobile users, that VLR shares this information with the home location register. We remember that the home location register stores the static information of a mobile users only once. So, that HLR is responsible for keeping track of its mobile user. So, VLR updates the current location area of the users and it shares or it gives the information to the HLR. So, HLR is able to locate the users. So, new VLR. So, whenever the mobile user is entering into the new location area, immediately the corresponding visitor location register will update its location and it shares the information with the HLR. So, that is referred as roaming. So, roaming is nothing but changing the VLRs without getting the disturbance with the services. So, three type of roamings. The roamings may be within the network of one service provider or sometimes national roaming. So, two providers can be used to provide the support for a single user. So, a particular mobile station can be moved from VLR of the different service providers. And international roaming. So, the users can move from one country to another country, still the users can be worldwidely located. So, now the concept of international roaming enables one device over several countries. So, without changing the SIM card, a user can roam around through different countries. We have discussed that the VLR updates the current location and it shares the information to the HLR. Now, the VLR uses several numbers to continuously locating the GSM user. Mobile station international ISDN number, international mobile subscriber identity, temporary mobile subscriber identity, mobile station roaming number. So, these numbers are used to locate the mobile station, that we will see one by one. So, the first one is mobile station international ISDN number. Actually, this is very important number. This is known as the cell phone number or mobile number provided to the user. This number is not associated with a specific device. Instead, it is associated with the SIM card or it is specific to the service provider. So, the mobile station international ISDN number has some format. So, first one is country code CC, national destination code, that is referred as NDC. This is the address of the network provider, and the last part is subscriber number, that is referred as SN. This is an example. So, here the mobile number is 491791234567. The first, that is the 49 is nothing but the country code used in Germany, 179 is the national destination code and 1234567 is the subscriber number. So, this is the format of MS ISDN. The second number used to locate the GSM user is International Mobile Subscriber Identity, IMSI. Actually, the IMSI is an internal unique identification. It is unique to a particular user. The format of IMSI consisting of mobile country code, mobile network code and mobile subscriber identification number, that is MSIN. The third number used to locate the GSM user is temporary MSI, that is temporary mobile subscriber identity. Actually, we know that the users are connected with the GSM network through the air medium. So, the real identity of the user should not be shown on the air interface. So, now TMSI takes care of that one. The real identity, that is the IMSI of the GSM user, is not used in the air interface. To hide the IMSI, GSM using the 4-byte TMSI number. So, this is the temporary number and the TMSI number is randomly selected by the current VLR. Some facts about the TMSI number are: the VLR may change the TMSI periodically and TMSI is valid temporarily within the current location. So, the moment the mobile user is moving to another one new VLR, the TMSI number will be changed. So, using the TMSI and location area identification, a subscriber can be located and the calls can be forwarded. The IMSI is not needed for the ongoing calls. The next number used to locate the mobile user is mobile station roaming number, that is MSRN. So, this is also a temporary address. This also hides the identity and the location of the subscriber. So, the VLR generates this address actually. The mobile switching center will make a request to the VLR. Based on the request, now the VLR will assign the new MSRN number. So, for the incoming call, the HLR can use this number to locate the mobile user. So, the mobile station roaming number contains current visitor country code, that is VCC, visitor national destination code, identification of the current MSC together with the subscriber number. So, these 4 numbers we have discussed are used to locate the GSM users at any time. We have discussed how the users are located in the GSM network. Now, after locating the users, we have to establish the connection. So, the connection can be originated or the request for the connection establishment may be from the mobile station, or sometimes a fixed station can make a request to the mobile user. So, 2 type of connection establishments are used in GSM. They are mobile terminated call, that is referred as MTC, and mobile originated call, that is referred as MOC. So, mobile terminated call is nothing but the call is established towards the mobile station. Another station may be the fixed station or some other mobile station. The next type is mobile originated call, that is referred as MTC. So, making a call from a mobile station is referred as the mobile originated call. Here, the mobile station will originate the call, that is why it is referred as mobile originated call. So, that call can be originated towards a fixed station or some other mobile stations of same or different service provider. The destination can be within the GSM network or outside of the GSM network. We will discuss how the mobile terminated call is generated. The basic steps for connecting a calling station with a mobile station. In the first step, the user is dialing the phone number of a GSM subscriber. In the second step, the fixed network or PSTN notices the destination code. The moment the PSTN receiving some information, it will contact the gateway mobile switching center. So, after getting the request from the PSTN network, now it is the duty of the GMSC or the gateway mobile switching center to check whether the mobile station is located. So, the GMSC identifies the corresponding HLR of the subscriber and it signals the call setup to the particular HLR. Now, in the next step, the home location register checks whether the number is existing or the requested services are subscribed. So, based on that, the further steps will be taken. In the step 5, the HLR requests an MSRN from the current VLR. We already discussed that the VLR is responsible for updating the current location of the mobile users. So, now in this step, the HLR making a request to the VLR to get the current location of the mobile user. In the next step, the HLR can determine the MSC responsible for MS and forwards this information to the GMSC. Let us stop our discussion at this point and we shall continue our discussion after the break. Welcome back. Before the break, we were discussing about the several steps about how the mobile terminated calls are originated. In the first step, a station is making a call to the PSTN network. So, the PSTN identifies that the mobile user belongs to some GSM service provider. PSTN contacts the corresponding gateway mobile switching center. So, in the third step, gateway mobile switching center contacts or identifies the corresponding HLR. So, in the fourth step, the HLR checks whether the services are subscribed or the number is existing. So, it will confirm. After confirming all this, the HLR will give the information. So, in the fifth step, the HLR requests an MSRN from the current VLR. So, after getting the MSRN number from the VLR, the HLR can determine the MSC. In the sixth step, the HLR is able to identify the mobile switching center which is responsible for the mobile user. So, let us start our discussion from the step 7. So, the GMSC can now forward the call setup request to the MSC indicator. In the sixth step, GMSC got information about the current MSC. So, from this point, the moment the corresponding MSC is fetched, the MSC is responsible for all the further steps. In the step 8, the corresponding mobile switching center requests the visitor location register about the current location of the mobile user, because the mobile users are keep on moving from one location to another location. So, the VLR is responsible for automatically updating the mobile users. So, now the visitor location register gives the information to the mobile switching center. So, in the step 9, the mobile switching center receiving information about the current location from the visitor location register. In the step 10, if the mobile is available, so because of the information given by the VLR, now the MSC is able to identify if the mobile station is available, mobile switching center initiates the paging. So, what is a paging? Paging is nothing but an operation of searching a mobile station within the cellular range. So, many base stations are connected or many towers are connected with the mobile switching center. So, a location area may belongs to various towers. So, the mobile station maybe belongs to any cellular range. So, now the mobile switching center has to page to locate the corresponding mobile station. So, once the paging signaling is initiated by the mobile switching center, all the towers will generate the paging signal and they will search the mobile station actually. So, in the step 12, 13, 14, the mobile station has to answer. If the mobile station is live for the corresponding paging signal, it will give the response back to the GSM network. So, in the next steps, that is 15, 16, 17, the VLR signals the mobile switching center to set up a connection to the mobile station. So, these are the steps used in the GSM network to establish a connection to a mobile station. So far we have discussed about the mobile terminated call. Now, we will map all the discussions in the diagram. So, in the first step, a station is making a call to the PSDN. Now, the PSDN is able to identify from the number of the mobile user and it will come to a conclusion that the mobile station belongs to a service provider. So, the PSDN is contacting the gateway mobile switching center. Now, in the third step, the gateway mobile switching center is making a request to the corresponding HLR, that is the home location register. In the fourth step, the HLR will identify whether the number is existing or all the requested services are subscribed. So, once that confirmation is over, HLR will contact the visitor location register in the fourth step. Now, the visitor location register is responsible for giving all the current location information about the mobile station. So, in the fifth step, the VLR, that is the visitor location register, gives the information to the home location register. So, that in the sixth step, the HLR will give all the informations to the gateway mobile switching center. So, after collecting the required information from the home location register, in step 7, the gateway mobile switching center will give the information to the corresponding MSC. Now, based on the informations retrieved from the HLR, the gateway mobile switching center is able to identify the right mobile switching center. So, the moment the GMSC gives the information to the corresponding mobile switching center, all the subsequent steps are taken care by the corresponding mobile switching center. So, in the step 8, once again the mobile switching center will get the information about the current location register. So, that is achieved in the step 8, and step 9 is one which gives the information to the MSC. So, after getting the current location area, the MSC will initiate the paging signal. So, that is shown in the step 10. Many basic service stations can belong to a particular or a single mobile switching center. So, based on the current location area, all the BSCs belongs to a single mobile switching center will generate a paging signal. So, that is represented the step 11. So, step 11 is nothing but the paging signals generated by the BSS. The mobile station will answer to the paging signal. So, in the step 12, the mobile station will answer to the paging signal. So, once again step 13 is used by the BSS to give the information to the MSC. 14, 15, 16 are the steps used to establish the connection back to the MSC. So, at every time the GSM network ensures the current location of the mobile user. So, 15, 16, 17 are nothing but how the connections are established. So, through 15, 16, 17 the connection is actually established. So, the flow is quite complex, including all the informations provided by the HLR, VLR. Now, the connection is established from the calling station to the mobile station. So, that is why it is referred as mobile terminated call. So, now the calling station is one that is originating the connection or that is making a connection. Now, the mobile station is the destination. So far we have discussed about the mobile terminated call. Let us start our discussion from mobile originated call. So, that is referred as MOC. Here also we have some basic steps. When compared with the mobile terminated call, the steps involved in the mobile originating call is somewhat less complex. So, one fact about mobile originating call is here we do not need the paging signal. So, that easily can make a request to the corresponding tower. Let us discuss the steps one by one. In the first step, the mobile station transmits a request for a new connection. So, the mobile station is connected with the tower through the air interface. Now, through the or the radio interface, the mobile station is making a connection to the tower. In the step 2, the basic service station forwards this request to the corresponding mobile switching center. In step 3 and 4, the mobile switching center has to do some checking operation, whether the MS is allowed to make a call, or sometimes the mobile station may request for some services, but that services has to be subscribed earlier. So, all the checking operations will be performed in the step 3 and 4. Once all the checkings are over, in the step 5, 6, 7 the call will be established. So, in the mobile originating call, definitely one mobile station is the source. The destination may be another one mobile station or the station of some other outside network. If all the resources are available, now the mobile switching center sets up a connection between the mobile station and the fixed network. Let us map our discussion about the mobile originating call to the corresponding diagram. So, in the diagram, now the mobile station is originating a call, that is represented as 1. So, in the second step, the corresponding BSS will make a request to the mobile switching center. In the step 3, the mobile switching center will ensure the current location, or it will get some information from the visitor location register. So, here the checking operation will be performed, whether the service are subscribed or not. So, that will be ensured in the step 4. Once the step 4 is finished, mobile switching center can establish the call between the PSDN network and MS. In the mobile originated call, the call is originated in the mobile station and it is ended with some station, maybe PSDN user. So far we have discussed that how the mobile originated call and mobile terminated calls are made. To make a connection or to establish the connection between the two entities of the GSM users, we need some extra control messages. Some control messages are exchanged between mobile station and BTS during the connection setup. BTS is nothing but base transceiver station, that is our actual tower. So, sometimes we used to hear these kind of messages as noise. While making a call, we used to hear some noise. That noise is nothing but the control messages exchanged before establishing the connections between the tower and the mobile station. So, paging is only necessary for an MTC, that is mobile terminated call. For a mobile originated call, the paging signal will not be generated by the BSC. So, that has to be mentioned in the control messages. So, the first step in the exchange of the control message is nothing but channel access. That is, The channel is accessed via the random access channel, that is referred as RACH. So, channel assigned could be a traffic channel or slower signal channel. So, before establishing the connection, security has to be ensured as well as authentication has to be performed. Now, the control messages also involving the security and authentication. So, the communication security is an operation that consisting of authentication of the mobile station. After authentication, that mobile station's communication channel will be switched into the encrypted communication. So, the data which is transmitted from the mobile station or to the mobile station has to be encrypted to ensure the security. If someone is calling a mobile station, it answers now with the alerting that the MS is ringing, and with the connect the user has pressed the connect button. So, this is about the connection establishment. If you are making a call to your friend's mobile, now your destination mobile will make a ring, so that that persons will be alerted that someone is making a call. If he willing to get the connection, he has to press the connect button, so that the call or the connection will be established between the two entities. Acknowledgement. So, after connection acknowledgement, both parties can exchange data. So, before exchanging the data, the acknowledgement has to be exchanged. Closing connection comprises an user initiated disconnect message. Both the persons, for example, someone is making a call to you, either you can stop the connection or the person who made a call can cut the connection. So, both the users can take the decision about terminating the call. So, closing the connection releases the connection and the radio channel. Once the connection is closed, the corresponding radio channels has to be collected back and it will be returned. Now, let us map our discussion about the control message exchanges in the diagram. So, this is mobile terminated call, this is our mobile station and the base transceiver station. Now, as this is the MTC, now the BTS is making the paging request and the MS will make a request about a channel, the channel will be immediately assigned. So, the paging response will be given back to the BTS and the authentications and the encryption, everything is ensured in the subsequent steps. After authenticating and encryption mode is over, the setup will ensure that the call is confirmed. So, assignment command is one used to assign the channel. So, the alerting message will be given and at last the mobile station will be connected with the BTS. Once the channel is established, the data or speech can be exchanged. In the case of MOC or mobile originated call, almost the signal or the control messages exchanged are same, but in the different direction. Here we can note one thing, that the paging request is not involved. As the mobile station is making the call, there is no need of making the paging signal. So, here also authentication and chippering operations will be performed and then the connection will be established, so that user can exchange the data as well as speech between the mobile station and the BTS. Let us summarize what we have discussed. GSM performs the automatic worldwide localization of users by doing the periodic location updates. The location area is not the precise geographical location. VLR, that is the visitor location register, informs the home location register about the location changes of the MS. Changing the visitor location registers with uninterruptible availability of services is known as roaming. The mobile phone number is not associated with a certain device, but it is associated with a SIM card. The real identity or IMSI of the GSM user is not used over the air interface. Mobile terminated call is about making a call to a mobile station. Mobile originated call is about making a call from the mobile station. Control messages are exchanged between a mobile station and base transceiver system during connection setup. It is exchanged in either direction. Let us pose some questions for our understanding. What is localization in GSM networks? How does a HLR get the current status of an MS? Differentiate national and international roaming. What is the advantage of using TMSI number? Explain the format of MS ISDN number. What is visitor national destination code? What is paging in GSM? Differentiate mobile terminated call and mobile originated call. Is paging required for mobile originated call? What is the reason for exchanging the control messages between base transceiver station and mobile station during a call setup? With this we conclude today's session. We shall discuss about the remaining GSM security routing protocols in GSM in the next lectures. Thank you.